Oh my goodness, how is this possible? Today, it's gonna be David versus Goliath. We've seen the new MacBook smoke so many machines, but you guys have asked, what about AMD's best mobile processors and NVIDIA's best mobile graphics card, an unlocked RTX 3080 that has full 160 watts of power? Well, that's what we're doing, and we have this huge 17-inch Maingear Vecor Pro that has some insane specs like 64 gigs of RAM, 2 terabytes of SSD, and RAID 0, a much bigger chassis with a high-end cooling solution, a huge 230 watt power brick to feed it all the power that this machine needs, compared to a tiny, slim 14-inch MacBook Pro on battery power. Now, this machine is so much smaller, but the price tag is not smaller, and that's one thing that some of you guys complain about. Sure, you get killer performance, but this laptop right here costs $4,099, and if you were to get a 16-inch model that's closer in size to this Maingear, that would cost $4,300. And guess what this machine costs with those specs? $2,700, and it has this 17-inch display, 1440p, 165 hertz. So you're definitely getting a lot of bang for the buck, but we're gonna see how it compares in some popular benchmarks and real world tests. I even got a few new ones as well that we are going to add in. Now, before we jump into that, I just wanna show you guys the difference size-wise. I mean, this is just incredible. The MacBook is much smaller. Obviously, it is thinner as well. Even though this Maingear actually isn't as thick as I expected, but it's definitely chunkier. And of course, weight-wise, my goodness. I mean, this thing is so much chunkier and heavier, but it does have some extra ports. For example, I like how the power adapter connects on the back here. Of course, you can't power this with USB Type-C, not enough power, but we have an Ethernet connector, we have HDMI, we have this USB Type-C. It does not have a Thunderbolt, unfortunately, because it is an AMD system. We have USB-A ports on one side, on the other side as well. And for some reason, a micro SD card slot, when our MacBook has a full SD card slot. I'm not sure why they would put that in such a big machine. Now, this laptop also has some cool features like Windows Hello. We don't have that with our Mac. Apple did not put that into the notch, but you have Touch ID to log in. And one thing I want to mention is the MacBook, even though it's so much smaller, it does have some advantages. Obviously, the trackpad, the keyboard, the speakers, even though it's much smaller. The display is also 10-bit DCI-P3 compared to this 17-inch display. It's an 8-bit panel, sRGB, not the same quality with the high brightness. Now, if you guys want a full review on this laptop, which has insane performance specs for the money, I will be putting one out in a little bit later, so make sure you guys subscribe down below. And then with that, you guys can help us reach our goal of 1 million subscribers. We would greatly appreciate it. But in this video, I want to just focus on performance with this NVIDIA 3080 with 16 gigs of VRAM and this CPU. Now, I want to start out with something that I'm super curious about personally, something I have not done before, and this is a file unzipping test. Now, that might seem silly, but sometimes you gotta wait forever. So this is a 16.6 gig file, and when I did this with an Intel machine, I mean, it was a lot slower, and I'm wondering what AMD can do. Oh gosh, okay. All right, so I've tried this multiple times. I don't know if it's just too much tiny files or what. It just keeps crashing on me when I'm trying to unzip it. It takes about 3 minutes on the M1 system. My other Intel system took about 15 minutes to do it. Yeah, well, I guess we're just gonna have to skip this test. I'll just delete that there, and let's move on. The other thing I'm very curious about is the performance of the SSDs in RAID 0 compared to Apple's fast SSDs, and of course, performance when we unplug from the outlet. So we're gonna test that next, but first, I wanna press this turbo button right here. There's a dedicated button on there for the best performance. So there you go, we're in turbo. That's the highest end mode to make sure we max out the performance. I'm gonna use AJ8 to test out since it works on both macOS and Windows. It does read a little bit lower than other applications, but at least it is fair. And take a look at that, guys. The Vector with RAID 0 SSDs is faster in write speed, slightly faster, but also about 400 megabytes per second slower in read speeds. Now, as I was downloading the benchmarking and real world applications, I just saw how quick this machine was in web browsing. It surprised me, super snappy, of course plugged in. So what I want to do is run speedometer, and we're going to see how well this AMD processor, this top of the line one, performs compared to this M1 Max chip, which of course has the same exact performance as the M1 Pro, the same 10-core processor. And wow, listen to that. The fans actually kicked in this web browsing test. I don't know if I've seen that before, but it looks like it's going pretty quick. And look at that, we basically have 200 with this AMD system compared to 270. It's still a 40% difference, but honestly, you don't notice it. Now that's practically the same as the best Intel laptop processor, but that Intel processor slowed down dramatically when we unplugged it. It was shockingly bad. So let's just go ahead, let's unplug it. This will be our first unplug test. We're not gonna do many of these, but I wanna go ahead and see, can we still maintain that really fast performance? And bam, look at that. I had my hopes up, and well, you guys see for yourselves, 152, so it definitely lost about a quarter of its performance. Still not bad, still a good score, definitely not as bad as Intel, so thank you AMD. You guys are maintaining more performance, but this is also kind of bad news for, say, some of the other tests if we do get a noticeable difference here. So with that said, let's go ahead and close this down. Let's plug that fat barrel plug back in and test out Geekbench 5. So as you see, both of these have 64 gigs of RAM. We got the 5900HX in this Maingear. Let's go ahead and run that test. And I am using Windows 10 on the system. That's because I'm going to be using a script to fully unlock the 3080 in the system. Out of the factory, it is locked, better performance than the Razer, but I want to make sure we have no limitations at all. And we're going to test that in just a sec. Wow, this thing is blaring with the fans. Oh man, hopefully that means some great performance. All right guys, the results are in, and with fans blazing, here is what we got. Single core, the Mac wins by about 18%. That's a great single core score for the Windows system. Multi-core score, we have a difference of 40%. Now, what I'm curious about is, will this performance stick like this when we unplug it? I don't think it will, but how much slower will it be? The Mac, of course, is unplugged on battery power. And when we get into the heavier tasks, not the mixed workload, where we have all these different tests that are being done, what are we gonna get there? Is the Mac gonna slow down with its limited thermal system? Let's go ahead and find out. We're unplugged, we're still in turbo mode, we're in the maximum performance on battery. Let's run that one more time. All right guys, it's a little worse than I thought. I was hoping for better. Single core, we have a difference of 50% now from 18%. And multi-core, instead of 40% faster for the Mac, we are now 95% faster in terms of CPU performance. Yeah, that's a big difference. Now, I still want to test the graphics unplugged, but I think as we move forward, I'm not going to be able to test each test unplugged. We're going to get drastically worse performance. Maybe I'll do one or two unplugged, we'll see. But this just shows the ability of this 14-inch Mac and the 16-inch to maintain full performance when it's unplugged, which is amazing that we could do that. It's a portable machine and an insanely fast machine. And now let's get into graphics, and just to show you guys, I do have the 3080 unlocked here. I just ran a test. Check out the power draw here, 165 watts, 164, 166.3. That's the full GPU with the GPU memory. Of course, has 16 gigs. The actual, just the GPU chip itself is getting about 130, 134, right around there. So it's fully unlocked from the factory. And the fans were blaring. So let's do our first test of just Geekbench 5 here, because it will test out a lot of different computational tasks. And bam, look at that performance. More than twice as fast for the Windows PC laptop, 215 times faster. Of course, this is a bunch of different compute tasks. And as we mentioned before, the Mac does it so quick that it doesn't even ramp up to the full frequency. Apple has probably some power saving options. So if it's a task that's literally a second, it won't give you maximum GPU performance, which might be unfortunate for this test. But but let's go ahead and close this down. And I'm gonna run GFXBench, which is both optimized for CUDA and Metal. We're gonna do the off-screen test because for this one, it's not going to change depending on the resolution, so it's gonna be completely fair. And our Maingear laptops fans are blazing. Listen to this. All right, guys, we have a result, and sorry, 32-core M1 Max, the RTX has it. So here we have a score of 231.5 frames per second with the unlocked 3080, an excellent score compared to 281. That is 14% better performance for the Maingear 3080 laptop. But with that said, if you guys watched our comparison against the 14 and 16 inch, the 16 inch actually performs at 310. So Apple actually underclocked, undervolted this M1 Max in the 14 inch save battery, but that's no excuse. That's exactly how it performs compared to this system here. Now we also have a difference in wattage. For this 14 inch, we're running at 35 watts compared to 165 watts. So that's close to 5 times more wattage required to get this performance. So I guess if you look at it that way, it's very impressive what we're getting. And of course, we can't forget this is on battery power. So now let's go ahead and see how these graphics can perform fully unlocked and no software limitations when we unplug it. Oh my goodness, how is this possible? We just got the results. It was silent the whole time this time instead of the fans blaring. But look at this difference. We have 280.5 on the Mac, so half an FPS difference for the average in that test. But the Maingear, 27.9, so let's call it 28 FPS. Wow. Is that why Apple, when they showed off their comparison charts, they said, hey, if we look at the best RTX 3080 that draws 160 watts, when you unplug it, the performance is literally horrendous, 3 times worse than the Mac. Now, I think this is worse than 3 times worse. That is crazy. And just to show you guys, we are on the best performance mode. We still got the turbo turned on, but does it really downclock that much when you're on battery power? So I guess I have to forgive Apple for slowing down the 14 inch compared to the 16 inch just to maintain battery life, where this one, I guess it probably can't even give that much power from the battery, so that's one thing, but then the battery drains so fast if it's literally drawing 5 times more GPU power. That's crazy, but I still would like to have a turbo mode for this Mac. And now it's time to show that AMD processor some love. We're plugged back in. I'm gonna run the multi-core test. I know this thing does not throttle. The fans just kick in insanely loud to keep it cool, which is great that it doesn't throttle. And the M1 also stays cool. So let's go ahead and see what kind of performance difference we get when our CPU's maxed out all the way. Man, I still can't get over how loud these fans are. It's incredible. Take a listen. Woo. All right, let's turn that back. Now, the 14 inch, you can definitely hear the fans compared to the 16 inch, which stays silent, but at this point, I can't hear them at all. And I am running a 10-minute test. I clicked on that, so let's just go ahead and see what our final score is gonna be. I still can't get over how loud this system is. Listen to this. That's crazy, but on the plus side, even though we're drawing 60 watts, there's no thermal throttling at all on this system. We are running at 87 degrees Celsius, so it's performing at the maximum, which is great. Whereas on our Mac, we're running at 97 degrees Celsius with our hottest performance core. Of course, the efficiency cores are running cooler, but with that said, even at the end of this test, Apple still is not running the fans at full blast. They're running them at what, maybe 75% right now. It starts at about 50 after a minute and slowly tapers up, but they never max them out. They don't want this to happen with the fan just being insane. On this system, technically, they could slow them down a little bit and still not throttle, but they want it to run cool. And bam, we are finished. This is crazy. This is very crazy. I was not expecting it to be this close, but we have a result of 12,303, super consistent with the Mac compared to our previous tests. Very, very good compared to 12,182. So yes, the AMD processor did get beat by the M1 10-core processor. Of course, we have 8 high-performance cores here, 2 efficiency that barely do anything compared to 8 high-performance cores on this AMD. Now, the performance is right there. The main difference is that this one ran at 60 watts with those super loud fans, and this one runs at 30 watts to get the same exact performance. So half of the power needed. And of course, it's on battery power as well. And now let's get into Blender. I have Splashbox here. I'm gonna run the render. We saw that the CPU performance is almost identical in Cinema 4D, which is for that rendering engine, but Blender's free. A lot of people use it. So I'm excited to see what difference we see. Now this test right here, you can download it, test your own system, but it mostly uses the CPU. We'll do another graphics test too. But I do wanna mention that Blender is not yet optimized for metal. So we'll still run that test, but let's see how these processors compare. And bam, they're both done. For the Windows PC, we have 29.63 seconds compared to 25.62. So the Mac, the 14-inch MacBook, is roughly 16% faster in this test. Maybe that's the unified memory kicking in there to help out. Now, a lot of you guys say, hey, you should try out Cycles. It takes a lot longer, but it's a better quality render. So I'm gonna go ahead and switch over to that, and let's hit render. Our CPUs are maxed out on both systems, and I wanted to check out their RAM usage, and the Mac is just using way more RAM. If we take a look, we see 30 gigs of RAM used here, compared to only 17.8, both having 64 gigs available. Now I'm wondering, is that because we're using unified here in the graphics in those previous tests? They have to share that same amount of memory, whereas here our 3080 has 16 gigs of its own memory. So we'll see if that goes into effect when we're doing, say, video editing. And our cycle render is complete here, and the Mac wins once again. It took 4 minutes and 12 seconds compared to 4 minutes and 33 seconds. So about, I don't know, 21 seconds longer. Not a huge percentage difference, but it did still win using half of the wattage. And it's interesting also the difference in frequency, because the 8 high performance cores here ran at basically 4 gigahertz compared to the cores on the Mac that ran at 3 gigahertz. So we have the frequency difference right there as well, by about 25% higher clock speeds. Now let's give the RTX a chance. I have the Party Tug project open. You can also download. Let's see which one compiles the shaders quicker right here, and then we'll run that graphics-based render. Bam, it looks like the Mac did it. Here we're about 50% as far as compiling all the shaders here. So that was pretty quick, even though we're not yet optimized for metal. I think it's gonna be another year or so until it supports it properly. But of course, in the meantime, people are still gonna be using Blender and rendering. And bam, the PC laptop just smoked through that. The fans barely started to spin up and it was done. It took 4 minutes and 4.75 seconds compared to 5.95, basically 6 seconds. So 25% faster here for this render, which it's definitely faster and it's nice and quick, but you would think it'd be a bigger difference if, for example, in the other tests, we saw a bigger difference in this, and in Geekbench for the overall compute, that was over twice as fast, and we are still plugged in here. So there you go, there's that result. And I'm gonna do one more test here. This is gonna be a memory test. They both have 64 gigs of RAM, but I wanna see how fast is the unified memory compared to the standard DDR4 that's in this system. This is gonna create a 20 gigabyte file that really tests out the memory performance. And look at that, our memory usage just shot up pretty high, and then once it rendered, it shot back down. This is a CPU-based task, so before it's slightly slower on the CPU for this thing, but look at this now. We have 31.9, basically 32 seconds for that render with the Maingear, and 17.76 for the 14-inch MacBook. That is almost twice as fast when we combine something that has a lot of polygons, say stuff for CGI, for movie studio use. When you really need a lot of memory and memory bandwidth, we see that massive difference in memory performance with Apple's unified memory. And now we are in Lightroom doing some photo editing. Both of these are gonna perform very similarly. Looks like when I'm switching photos, surprisingly, compared to the Intel systems, the AMD is taking a little bit longer, so it is lagging behind slightly. I don't know if that's RAM or what that is, but overall, zooming in, nice and smooth. Using brushes, nice and smooth on both. Slight lag right when you start. It's the same thing on both of these systems. I'm gonna go ahead and Command undo. So as far as the editing experience, of course you have a better screen here. This is a larger screen, but let's go ahead and see our performance when we export these images. Bam, we are off. We've done this before against Intel systems, but I'm curious how the AMD system will compare. All right, wow, I don't know if this is a fluke. I don't know if it's AMD and the memory. I don't know what, but our Mac is almost done right here, where this is quite a ways behind. Bam, we are done. Wow, we have 2 minutes and 12 seconds. I guess that's pretty respectable for the Vecor Pro at 64 gigs of RAM, AMD's best GPU, compared to 1 minute and 19 seconds for the Mac. I think once again, that unified memory is what's doing it, because the CPU performance under full load, like we saw in Cinebench, is pretty dang close. Very, very close. But here, we see that difference. That is 67% faster. Wow, okay. Well, maybe that kind of makes sense why when we're switching images, it is a little bit slower, even though we have RAID 0 SSDs. So that is pretty crazy. We have David versus Goliath here, and so far, David is winning, which I guess in the story, it makes sense, David wins. But lastly, let's go ahead and open up video editing, and we'll see if the RTX can redeem itself in this laptop that costs so much less money. All right, guys, now let's jump into video editing. And I'm just gonna skip the stuff that we know the Mac is gonna defeat the Maingear in. Obviously on battery power, we saw how slow the graphics card gets, insanely slow. We're not gonna test that. I don't even wanna test these easy codecs right here. We know that the M1 Max chip has double encoders and decoders, so it's gonna fly through that. I just wanna do some tough tests. So let's just go to color. We are going to stabilize this 20-second 4K clip. Now, in the past video where we did the 16-inch against the Razer, the 16-inch was slightly faster, even though the raw graphics is a lot more powerful on the Razer, just because of optimizations. But here, we have an unlocked 3080 compared to an artificially limited and underclocked M1 Max. So this is gonna be interesting. This Maingear's 3080 should win. Let's hit stabilize. Start our timer. Bam, look at that, guys. Wow, that was a crazy difference right there. That was 3 seconds on the Razer to stabilize it, compared to 9 seconds, 3 times faster. That is incredible. And I think previously on the Razer, it was 10 seconds to do it. So I guess it's just hitting that 165 watts. And because it's done in 3 seconds, it doesn't heat up fast enough. Next, this is a 4K, 4-camera, multi-cam and a 4K project with LUTs, film grain. We have 2 clips reversed. It looks like as far as playback, we had a little bit of stuttering on the 3080 at first, but now it's running fine. And our Mac also is having no issues. Now, back in the day, this would crash video editing programs trying out this test. Looks like our RTX is running at 62%, so it's not even maxing out the graphics. And our MacBook looks like to be even less than 50% in order to process this. It's interesting that the Mac actually has more overhead when it has less graphics processing, maybe just efficiency. And now let's step up to a tougher project here. This is 6K Blackmagic RAW. Both of them are playing it back equally well, and I didn't really want to test, ProRes or whatever. We have decoders for that, or encoding. I just want to throw the toughest raw stuff at it to test out the RTX. So here we go, we have great playback. But now let's go ahead and export this. I'm gonna go and switch it over to MP4. We're gonna select H.265. That way we can use the encoders that are built into the RTX. So I'm gonna select NVIDIA here. It's about 2 to 3 times faster than using just the software-based encoding. Okay, so we got that selected. And let's hit render on this 5-minute project. And right away, both graphics cards are completely maxed out. That looks like it's our limitation right now. I'm really excited to see these results because in the past when we tested this, we had the 16-inch that has higher clock speeds, more wattage, extra graphics performance, and now we're basically doing David versus Goliath, the limited one compared to the unlimited 3080, faster than that Razer. And so far, it's looking to be pretty close. All right, guys, we have our results, and man, we have 2 minutes and 21 seconds for this 5-minute 6K project, Blackmagic Raw for the Razer, compared to 1 minute and 53 seconds. That is crazy. Both limited by the graphics. That just shows you efficiency with software, and even though you can have a lot more raw performance, doesn't always mean it's gonna be faster. Stabilization, it was a lot faster. That was just pure raw performance. Now, the same exact graphics in the 16-inch is 1 minute and 15 seconds. A lot faster than the 14-inch. This just shows that this test is pushing the machines to their limits. That's where we're seeing a big difference, but it still ended up beating this RTX laptop when it's plugged in. That is crazy. Now, you know what I'm gonna do? I'm gonna hit render all. I'm gonna hit render again. Let's let it get started. All right, it looks like 2 minutes remaining, 2.5 minutes. It's catching up, so click close to what it showed before, 217. I wanna see what the performance is gonna be like if I just go ahead and unplug it right now. What is it going to change to? I don't know if I'm gonna wanna wait that long, but I just wanna do this because I did mention to you guys that maybe I'll do that on another unplugged test at the end. So it looks like right now, so far, we're up to pretty much 5 minutes remaining, 6 minutes remaining now, 7 minutes, 8 minutes remaining. You guys basically get the point of the performance if you're on battery. So this is it, basically a portable desktop. You should treat it as such. So what did we learn? Well, just like the intro, David versus Goliath. Yes, Goliath is more powerful, larger, heavier, cheaper in this case, but when it comes to optimization, it's crazy what this 14-inch can do. So thank you guys for watching. Click above if you guys want to subscribe and help us reach our goal of 1 million subscribers. Check out one of those great videos right over there. If you want the full review, make sure your notifications are enabled. This has been Max, and I'll see you in the next video.